Today's lesson is 5-3, and we are going to be learning more about exponents. So we learned about it in our last set of notes, 5-2, and we had to actually add the exponents. Remember? So when we were multiplying like 2x times 3x, we would get 6x squared. We would add those exponents together. Well, today what we're doing is we are taking a term and we're raising that term that has an exponent to an exponent. So basically we're taking and raising a power to a power. And when you raise a power to a power, you are multiplying the exponents. So powers raised to a power, you're going to multiply the exponents. In this case, if I have n to the power of 3 raised to the power of 7, thank you, then I'm going to multiply my two exponents together, and I'm going to get n to the power of 3 times 7, which is n to the power of 21. Yes. Yes. Yes, you can. Not in this, not on, if, not on, not on the easy ones. So once you get to like a negative exponent, you need to show that you're moving your negative exponents around. And if you missed that lesson, you'll have to go back and watch it. Yes. Yes, you can work on this homework sheet. All right. Example 2, we have n to the power of 9 times 1/2. Remember, when we have fractional exponents, leave them as either proper or improper fractions. Do not change them to mixed numbers and do not change them to decimals. So this is just n to the power of 9/2. Okay. So that's all we're doing here. Now, if you come across a negative exponent, you're going to have to move it. In this case, example 3, we have n to the power of 2/3 times 1/2, which equals n to the power of 2/6. Reduce your fractional exponent. So the final answer would be n to the power of 1/3. Go ahead and do example 4. So do I have any questions on these first 4? Okay, so now we're getting to negatives. So we're going to take n to the power of 3 times -5, and we get n to the power of -15. But remember from our first lesson, I think it was, we do not want to have negative exponents, which means we have to move it down to the bottom of the fraction bar. Okay, so I'm going to move this down, and then I end up with 1 over n to the power of 15, because when I move it across that fraction bar, it gets rid of the negative exponent. All right. So now we have r to the power of 1/4 times a -12 is r to the power of -3. Again, we need to move that to the bottom, so it should be I'm sorry, not r. 1 over r to the power of 3. Any questions on those? Okay, now I want you to look at this one. This is saying we have r to the power of 1 I'm going to rewrite this. R to the power of 1 times r to the power of -6 raised to the power of -4. Now, following order of operations, what we want to do is we want to do our exponents first. So we need to do this part first. We need to raise those raise the -6 to the power of -4. So it's r to the power of 1 times r to the power of -6 times -4. Right. Which is r to the power of 1 times r to the power of 24. Now we're going back to last week's lesson. When you multiply two of the same bases together that have exponents, what do you do with those exponents? You add them. So this is r to the power of 25. And if you wanted just a little reminder here, it's r to the power of 1 plus 25. So this one's very similar. So go ahead and do example 8 and then check your answer up here. Okay. All right, we're going to move on. So here, all we're doing is we're now adding a coefficient into the mix. Anytime you have an exponent on the outside of a parenthesis, you want to apply the exponent to both expressions within the parenthesis. So I'm going to apply the 3 to the 5 and to the a. So I have 5 to the power of 3, a to the power of 3. And you do need to simplify this out. So if you need to use your calculator, you can. 5 to the power of 3 is, anyone know? 125 a cubed. And that is your answer. But what happens when I have a negative? Now you can start off automatically by moving the 4g down to the bottom because you know that with a -3, you can't have a -3, right? Okay. Or you can apply the negative exponent, then move it. It really doesn't matter. So I'm going to go ahead and apply my negative exponent first. And I get 4 to the power of -3, g to the power of -3. But I can't have negative exponents, so I have to move them down. So I end up with 1 over 4 cubed g cubed. And what is 4 cubed? 64. So I have 1 over 64 g cubed. All right, let's move to example 11. Again, I'm going to apply the negative exponent to both the 4 and the g. So I have 4 to the power of -3 and g to the power of -5 times -3. Now you could skip that step if you wanted to and go straight to 4 to the power of -3, g to the power of 15. So I just multiplied -5 times -3 to get 15. But I can't have a negative exponent, so I have to move that to the bottom. So I have g to the power of 15 over 4 cubed, because when I move my negative exponent down, it gets rid of the negative exponent. And my final answer is g to the power of 15 over 64. Now, I did a lot of steps here. You could have just done this in 2 steps. All right, go ahead and do example 12 on your own and then check it up here. Your answer? Any questions? Okay. These are a little bit more lengthy. I want you to understand here that this AB cubed has an exponent of 1 on the outside. And notice that the two bases, AB cubed, are the same. Does anyone know what the first step is in this problem that we might do? All right, yeah. Exponent. What would you do with the exponent?
Wait, that's 0, never mind.
Mm-hmm. You mean like -1 plus 1?
Would you put the first AB cubed on the bottom?
Yeah, you can do that. All right. Sometimes students can kind of see what this is and shorten the whole problem up a little bit if you visualize it or if you see it for what it is. If you can't, though, I'm going to do it the longer way, though. So, yeah.
Isn't it just 1?
Yeah.
Mm-hmm. Yeah. So you have the exact same base. And remember, when you have the exact same base and you're multiplying them together, you just add your exponents. So really what this is it's AB cubed to the power of -1 plus 1, which is AB cubed to the power of 0. And anything raised to the power of 0 is 1. But you can only do that if they have the same base. Okay, if this was AB cubed and A cubed B, you couldn't do that. Okay, so then this would be your final answer here. So let's look at this next one. This one, you have x to the 5th, y to the 4th raised to the power of 7, and then you have the same base, x to the 5th, y to the 4th raised to the power of -8. So it's the same process. You're just going to add your exponents. So I have x to the 5th, y to the 4th raised to the power of 7 plus a -8. Which is x to the 5th, y to the 4th raised to the power of a -1. But we can't have that, right? So we're going to move this whole term down. I'm sorry? Because 7 plus a -8 is a -1. Yeah. So now we have 1 over x to the 5th, y to the 4th. And you could put a parentheses and raise it to the power of 1, but it just makes it this right here. Now, I want to show you something really quick. You could have applied the 7 to and the -8 to all the exponents and multiplied them all together and then added and subtracted. That would have been fine too. This is just a shorter way. Okay, let's go to the back. We're going to go to scientific notation. In scientific notation, nobody wants to multiply this out 4 times. 3 times 10 to the fifth times 3 times 10 to the fifth times 3 times 10 to the fifth times 3 times 10 to the fifth. So what you're going to do is you are going to apply the exponent to both the 3 and the power of 10 separately. So you have 3 raised to the power of 4 times 10 to the fifth raised to the power of 4. Okay. Remember, when you have a power raised to a power, you're going to multiply them. So we're adding a rule in here in this lesson. Don't forget that. So 3 to the power of 4. Anyone know that off the top of your head? Yep.
27. No,
81. 81 times 10 to the power of 20. And remember, with scientific notation, we do use that x. I put a raised out, but we use the x. Now, based on what we learned last Friday with scientific notation, what is the one final step we must do to accurately write it in scientific notation form?
Gotta make the first number less than 10, or like this. We gotta move the decimal point.
Right, we have to move the decimal point behind the first number. Where is our decimal point here?
Behind.
Yeah, it's behind the 1. It's at the end of the number because we don't see it. And the proper way to write scientific notation is to move that decimal behind the first number. Now remember, if you move it to the left, you're adding 1. If you move it to the right, you're subtracting 1 from the exponent. Since we moved it 1 place to the left, we're going to add 1 to the exponent. I know this is a lot of information. So our final answer is 8.1 times 10 to the power of 21. Great. Let's go to example 16. Start at the first step. We're going to apply our exponent to both the 4 and the power of 10. So we have 4 to the power of 3 times 10 to the power of, and I'm just going to skip this first step. 12 times 3 is 36. What is 4 to the power of 3? 64 times 10 to the power of 36. Now we need to move our decimal. Since we move it 1 place to the left, we're going to add 1 to our exponent. 6.4 times 10 to the power of 37. Wow, a lot of yawning going on over there. Okay, I want you to try 17 on your own. Let's try 17 and 18 on your own, and we'll come back and check our answers. So I'm going to pause the video. Okay, so go ahead and check example 17 and 18. The one thing that I want to make clear is that in example 18, because we moved our decimal twice, we had to add 2. So you're adding to the exponent the number of times that you move the decimal. Any questions? Anyone need me to wait so we can process before we move on?
I thought you said you can't have a negative exponent. No, if you said you
In scientific notation, you can. Otherwise, you can't. But I'm glad you asked that question. Yes.
You may not have the sign.
Okay, that's not a valid question. Okay, let's go down to the bottom. How to determine a missing power. We did this in the last assignment when we were adding exponents. So remember that when we have a power raised to a power, we have to multiply these two together to get 15. So I'm going to take 5 times x to get 15, which is the same as 5x equals 15. And then I'm just solving that to figure out what my missing power is. And yes, you can do this in your head. But when you get down to problems like 25 and 26, you may not be able to solve them in your head. So that's why I'm showing you the process. So then we would just divide both sides by 5. And we know that the missing power is 3. Okay. I'm going to have you do the left side on your, I'm sorry, the right side on your own. Let's go down to example 21. Okay, I know that x times 4 is going to give me 4/3. I need to figure out what that x is. So I'm going to take 4x and set it equal to 4/3 because I know 4 times x should be 4/3. And I'm going to solve. How do I solve this for a variable? Yeah, not in your head.
I can't over it in my head.
You could divide by 4 or you can multiply by the reciprocal. So I'm going to multiply this by 1/4. And the reason I'm multiplying it by 1/4 is because the other side is a fraction. Multiplying by the reciprocal is the same as dividing. Yeah. Well, do you know what 4 times, do you know 4 times what the x is in this one without showing your work?
Yes. Yeah, 1/3.
Oh, well, aren't you smart? Yes, I do want you at least to set it up, okay? Yes, but the computer can also give you this answer. I want to make sure you know the process.
No,
What's it called?
There are ways. All right, let's go down to example 23. Okay, this one's interesting. What is the exponent to this c right here? It's 1. It's 1. So basically, we're figuring out 2 times what number gives us 1? Yep, it's 1/2. So you divide both sides by 2. And x is 1/2. Okay. All right, example 25. Well, we're trying to find the x, so we're just working with the b here. So we know that 3 times x is going to give us, there's no b over here. What happened to our b?
it's a 1. Because when you times something by 1, it can be.
Well,
Because there's no b there, so the b would have to be power of 0. Then when you multiply it by 3, it would still be a 0, and then multiply everything else to be just fly away because like it's you multiply it by 1 and just.
do you guys get what he's saying?
Yeah.
Okay.
I basically I got 1.
Notice that the b is not here. That means that the b became a 1. What? How do you get a 1 from an exponent? It has to be raised to the power of 0. So that means that your b had to have been raised to the power of 0 when multiplied by 3 because b to the power of 0 equals 1. So x is 0. Now, I don't know who all if you missed, Emmy, you weren't here, right? And Cortland, you weren't here. So if you guys missed last Friday's lesson, that might be a little bit confusing. So I'd go back and watch it. Okay. I am going to do examples. Actually, I want you to do 20 and 22 on your own if you have not done so. And then I'm going to do 24 and 26 with you. So I'm going to pause the video while you work on those two. Check 20 and 22. And then we're going to move into the last two. Example 24, what would you have to multiply 2 by so that this whole thing turns into a 1? 0. So x here, a squared raised to the power of 0 is going to give you a 1. Because remember, when you have a to the power of 2 times 0, you get a to the power of 0, and anything raised to the power of 0 is 1. So in this case, x equals 0.
Two to the power, if two to the power of 0, wouldn't that make 2 1, and then wouldn't it have to be a 1?
You have to, in order for this whole thing to turn to 1, it has to equal, exponent has to be a 0. Okay, this one's a little interesting. Notice, what'd you say? Yeah, it has to be a negative because we ended up moving it to the bottom of the fraction bar. So we know that 2x is going to give us a -6 and 4x is going to give us a -12. Because if it were on top, it would be a negative. So when we divide these, okay, x equals -3 and x equals, oh wait, I put a 2 instead of a 4, sorry. X equals -3. So in order for this one to work, our x would have to be a -3. And then we would end up with a to the power of -6, b to the power of -12, and then we'd have to move it to the other side of the bottom to make them positive. And then that's how you would get this right here. So our answer is that x equals -3. You have to know the rules for it. Yeah. All right, and that concludes lesson 5-3, more multiplication properties of exponents.